NDI Bridge securely shares NDI sources between remote sites, connecting NDI networks around the world, making it easy to set up and manage NDI workflows regardless of location. NDI Bridge sends video and audio signals across local and wide area networks. Each signal includes alpha channel, PTZ controls, tally, metadata, KVM, and more. It can also transcode signals between NDI and NDI-HX to maximize bandwidth and flexibility. And when used in conjunction with NDI Access Manager, NDI Bridge can share specific sources across wide area networks. You can download it for free as part of the NDI Tools Pack, available at ndi.tv. NDI Bridge features 3 modes of operation: host, join, and local. The host mode and join mode work in conjunction to join remote sites. On the first network, we will call it Network A. NDI Bridge is run on one system in host mode. It looks at the network and references the NDI signals available. Then, on the second network, we will call it Network B. NDI Bridge is run on one system in join mode. It also looks at the NDI signals on its network and references those signals. The host system on Network A makes itself available for connections, and the join system connects to the host. Once a connection is created between the two bridge systems, signals from Network B are available to Network A. And because NDI is bidirectional, all of the signals from Network A become available to Network B. NDI Bridge is aware that not all signals can be sent at all times, so it only sends the needed signals when they are being actively requested by a remote destination. Additionally, if another network joins the host, all 3 sites are now sharing their signals between each other. Here's how it works. We will start with the system on Network A. You can launch NDI Bridge from the NDI Launcher or your Applications menu. Start by clicking the Host mode. In the first field, you can enter the names of the Access Manager groups you wish to share, or leave it blank to share all public NDI signals. In the second field, you can enter the name of your bridge system. The public IP address will be entered automatically for your specific network. Next, you need to enter the port on your network. You must port forward through your router to allow for external connections. Lastly, you can enter a private encryption key, or the system will generate one automatically. You can quickly copy these settings to the clipboard for sharing with your remote operators. The encoder settings are where you can define how the signals will be shared across the wide area network. You can reduce bandwidth needs by transcoding all signals to NDI-HX using HEVC or H.264 encoding with compression settings you can adjust for your needs and capacity. Signals can also be encoded as high bandwidth NDI for use in workflows that do not have NDI-HX compatibility. Or you can choose to not transcode these signals and they will pass through in their native format. Lastly, click the Start button to start the NDI Bridge host. Now that the host is up and running, the next step is to join that host from another system. After starting NDI Bridge, click the Join tab. In the first field, you can enter the names of the Access Manager groups you wish to share, or leave it blank to share all public NDI signals. In the second field, enter your bridge name. In the next 3 fields, enter the server IP address, port, and encryption key from the NDI Bridge host system. Encoder settings are configured here as necessary for the bandwidth available. Lastly, click Join. Once the 2 networks are connected, you will be able to monitor the number of connections and bandwidth used at the bottom of the window. Now that the bridge is active, NDI signals from both networks can be monitored and used as desired. And here is an example. On the host system on network A, open NDI Studio Monitor. Select the bridge system in your device list. Any of the devices shared by the remote network B and their connected NDI signals can be monitored. These signals are now available to all NDI-enabled devices on network A. And because this is bidirectional, NDI-enabled devices on network B now have access to the NDI signals on network A, with all of the NDI features like alpha channel, PTZ control, tally, and KVM. The last mode is local mode. NDI Bridge in local mode runs on a single computer. It works efficiently to find NDI sources on the local network and creates a proxy for each source. It then uses that local computer as a new distribution point for new NDI signals. For example, if an NDI encoder is connected to a camera and many systems wish to view it, NDI Bridge can be used to move the bandwidth needs from the encoder, which has limited resources, to the bridge system, which can be configured with higher capacity components like a 10 gigabit network interface. Additionally, the transcoding capabilities of NDI Bridge mean that a single system can take a high bandwidth NDI signal, convert it to NDI-HX, then redistribute the NDI-HX signal across the network, reducing the bandwidth needed to send that signal to other NDI receivers, including local devices using Wi-Fi or remote devices over a VPN. Lastly, NDI Bridge can also be used to transcode NDI-HX signals into high bandwidth NDI signals to connect to NDI devices that may not have NDI-HX compatibility. To set up Bridge in local mode, simply select the Local tab. Enter any access manager groups, and lastly, enter the bridge name. Adjust the encoder settings as desired and click Start. Now, any system on the network has access to the bridge signals through the bridge system, moving bandwidth and transcoding requirements to systems configured with greater resources. NDI Bridge allows users to securely share NDI sources between local or remote sites anywhere in the world, making it easy to set up and manage. This gives media production teams the tools to reduce complexity and costs without sacrificing the quality and flexibility that NDI has to offer. Download NDI Bridge as part of the NDI Tools Pack today at ndi.tv.